type the words, "an astronaut riding a horse on Mars." Within seconds, a machine that fits in a server rack somewhere in Virginia or Oregon will generate a completely new, original image of that exact scene. It might be photorealistic. It might be in the style of Van Gogh. It's your choice. This isn't science fiction anymore. This is generative AI. And this creative explosion, the ability to conjure art and text and code out of thin air, is the most visible part of a technological revolution that's happening right now. But how does a machine create? How does it go from being a librarian that just finds information to an author that writes a whole new book? The answer lies in a fundamental shift away from the AI we thought we knew.
For most of its history, AI has been what we call discriminative. Think of it as a brilliant but uncreative librarian. Its job is to sort and classify. It can look at an email and tell you, this is spam. It can analyze a photo and say, that's a cat. It can look at financial data and predict if a stock will go up or down. It's incredibly useful, but it's always working with existing information. It sorts, it categorizes, it predicts. It can't create anything new. Generative AI is the polar opposite. It's not the librarian, it's the author. It doesn't just identify the cat in the photo, it learns the fundamental patterns of what makes a cat. The texture of fur, the shape of the eyes, the way the whiskers are positioned. And then, when you ask it to, it can generate an image of a brand new cat that has never existed, pixel by pixel. It doesn't just identify a well-written sentence, it learns the rules of grammar, the flow of narrative, and the rhythm of poetry. And then it can write you a sonnet about the loneliness of space in the style of Shakespeare. It synthesizes, it invents, it generates. This leap from sorting to creating is the entire game. But the how is where things get truly mind-bending. How do you teach a pile of silicon and code to understand the essence of language well enough to write a story? The process is both brutally simple and impossibly complex. You start by feeding the AI model an absolutely colossal amount of data. For a language model like the one behind ChatGPT, this means a significant chunk of the entire internet. Books, articles, websites, conversations, petabytes of it. But here's the critical part. It's not memorizing any of it. It's not creating a giant database to copy from. Instead, as it processes this ocean of data, it's learning the patterns. Think of it like learning to cook without a recipe book. By looking at thousands of finished dishes, you start to understand the underlying principles. You learn that certain ingredients go together. You learn that heat changes texture. You learn the basic structure of what makes a meal a meal. That's what the AI is doing. It's learning the statistical relationships between words. It learns that the word queen is often found near king or England. It learns the structure of a question versus a statement. It learns the subtle differences in tone between a formal email and a casual text message. It's building an internal, multidimensional map of how human language and ideas connect. So when you give it a prompt, like write a story about a detective who is also a baker, it doesn't search for that story. It navigates its vast map of patterns and predicts the most likely next word, then the next, weaving together a completely new narrative that fits the patterns it has learned. This process creates incredibly powerful AI, but for a long time, it was wildly inefficient. You'd spend millions of dollars training a model to do just one thing. But then, a new idea emerged, a concept so powerful it would become the bedrock of this entire AI revolution. This is the part of the story that most people miss. The magic we see in apps like ChatGPT or Midjourney isn't just generative AI. It's a specific type of engine making it all possible. They're called foundation models. The old way of doing things was to build a separate AI model for every single task. You'd build one for translating French, another for answering customer service questions, and a third for writing marketing copy. Each one was built from scratch. It was slow and expensive. Foundation models flipped that entire idea on its head. The concept is simple. What if we built one single, absolutely enormous model and trained it on a massive general data set? That huge slice of the internet we talked about. This pre-training process is unbelievably expensive, costing hundreds of millions of dollars and requiring more computing power than a small country. But once it's done, you have a foundation, a master model like GPT-5 or Google's Gemini that has a general purpose understanding of language and concepts. From there, you can take this single foundation model and quickly adapt it for thousands of different specific tasks. This is called fine-tuning. You give it a much smaller, specialized dataset, and in a fraction of the time and cost, you can turn the generalist model into a specialist. It's like building one giant power plant instead of putting a tiny generator in every house. The power plant, the foundation model, provides the raw energy. Then you can plug anything into it. A light bulb for writing emails, a toaster for generating code, or a TV for creating images.
This one model to many tasks approach is what led to the explosion of AI tools we see today. This idea of a single massive all-purpose model is the game changer, but it was only made possible by a single brilliant breakthrough in 2017, a paper with a deceptively simple title that completely rewrote the rules of AI. Before 2017, AI models had a major problem with memory and context. When processing a long sentence or paragraph, they would often forget what the beginning of the sentence was about by the time they reached the end. Then, a team of Google researchers published a paper titled "Attention is All You Need." It introduced a new architecture for AI called the transformer, and its secret weapon was a mechanism called self-attention. In simple terms, self-attention allows the model to look at all the words in a sentence at once and figure out which other words are the most important for understanding each specific word. Take a sentence like, "The bee landed on the flower because it wanted nectar." For a human, it's obvious that "it" refers to the bee. But for older AI, that was a huge challenge. With attention, the model can instantly weigh the importance of all the other words and correctly calculate that "it" is linked to bee, not flower. It's like giving the AI a smart highlighter that automatically marks the most relevant context. This might sound small, but it was a nuclear-level breakthrough. It allowed models to understand nuance, long-range dependencies, and complex context in a way that was never before possible. More importantly, the transformer architecture could be massively parallelized, meaning we could use thousands of computer chips at once to train models that were hundreds or even thousands of times larger than before. The attention mechanism didn't just improve the models, it made the entire foundation model concept feasible. It unlocked the door. And now that it's open, this new form of intelligence is pouring into every corner of our world, acting as a force multiplier in ways we're only just beginning to comprehend. This isn't just about writing better emails or making funny pictures. This technology is becoming an indispensable co-pilot for high-skill professions everywhere. In medicine, foundation models are being trained to read medical scans and identify diseases with a speed and accuracy that can surpass human experts. They can analyze millions of research papers in a single afternoon to help scientists find new pathways for drug discovery. In software development, tools like GitHub Copilot, built on a foundation model, act as a pair programmer for developers. It can write entire functions from a simple English description, spot bugs, and slash development time in half. It's not replacing programmers, it's making them superhuman. In science, it's accelerating research in fields from climate change modeling to material science. In law, it's summarizing complex legal documents. In education, it's creating personalized tutoring for students. The common thread here is partnership. We are at the very beginning of a new era where cognitive work is no longer a purely human endeavor. But with any technology this powerful, a shadow follows the light. For every incredible application, there are serious risks we absolutely have to confront. Foundation models are not objective, all-knowing oracles. They are mirrors. They are trained on the internet, which is a reflection of humanity, including all of our biases, prejudices, and flawed information. If a model is trained on data where doctors are usually depicted as men and nurses as women, it will perpetuate that stereotype in its own outputs. Then there's the problem of hallucinations. This is a sanitized term for when the AI simply makes things up. Because its goal is to generate a plausible sequence of words, not to state the truth, it can confidently invent historical facts, cite academic papers that don't exist, or create fake legal precedents. In a casual chat, it's a funny quirk. In a medical or legal setting, it's a disaster waiting to happen. And of course, there's the threat of malicious use. The same technology that can generate beautiful art can also create hyper-realistic deepfakes to spread misinformation and propaganda on a scale we've never seen before. It can be used to craft perfectly tailored phishing emails to scam people out of their life savings. These aren't hypothetical problems, they are happening right now. And they force us to ask incredibly difficult questions about trust, truth, and safety. These challenges are enormous, but they aren't stopping the march of progress. So where is all of this heading? What does the next chapter in this story look like? The future of this technology is moving towards multimodality. The next generation of foundation models can already see, hear, and speak. You can show it a picture of the inside of your fridge and ask it to generate a recipe. You can have a real-time spoken conversation with it. It's breaking free from the text box and beginning to understand the world in the same way we do, through a combination of senses. Ultimately, generative AI and foundation models represent a historic shift in our relationship with machines. For all of human history, our tools have been extensions of our physical bodies. A hammer for our arm, a car for our legs. Now, for the first time, we are building tools that are extensions of our minds. We are moving from a world of command and execution to one of collaboration and creation. The line between human thought and machine intelligence is blurring. The journey ahead will be filled with incredible opportunities and profound challenges. But one thing is clear, we have created a new kind of partner in the quest for knowledge and creativity, and our world will never be the same.
If this deep dive sparked your curiosity, consider liking this video and subscribing to the channel for more explorations into the technology that's shaping our future. Thanks for watching.